Question 22, October 2020 paper. In this question, it tells you B and C are compounds of two different transition elements. A student carries out test tube reactions on aqueous solutions B and C. The observations of the student's tests are below. Now, if you look at test number 1, you're adding dropwise ammonia, and in one, you've got a green precipitate, and the other one, you've also got like a gray-green precipitate. Now, when you're adding excess ammonia, one, there's no further change, but the other one, there is it gives you a purple solution in excess ammonia. So in this question, it wants us to analyze the results to identify B and H, B2H, and construct ionic equations for the formation of products D and H. D, E, F, where's F? F, G, H. Okay, now let's look at with the green precipitate forming and the purple solution forming in excess ammonia. Let's look at the color chart that we've used before. You see, when we're adding ammonia, so green precipitate, when we're adding ammonia, you're looking at, you've got a dark green precipitate. You see, when you're adding dropwise ammonia, that dropwise ammonia is forming hydroxide ions. Those hydroxide ions are ones that go on to form the hydroxide of it. So actually, you're forming iron 2 hydroxide. Now, when you're adding dropwise ammonia, and it gives you a green, it said a gray-green precipitate, but on excess ammonia, it gives you a purple solution. That strongly suggests that we're dealing with this setup here. So, and you've got the excess ammonia to give you a purple solution. Ladies and gentlemen, you need to learn all these colors, memorize them, and yeah, these are easy marks. So, and you want to memorize them so that you can recall them, whenever you need them. Going back to the question. So, green precipitate D. Let's look at D. It forms a green precipitate. This is likely to be, as we said, Fe2+ ions. And the precipitate forming is from adding ammonia, which it then reacts with the hydroxide ions. You see in dropwise ammonia, hydroxide ions form. How do they form? They form like this. Forms an ammonium ion. And some hydroxide ions. And those hydroxide ions go on to form the precipitate, FeOH2. We'll put our state symbols in. That's compound D. Compound E now, the only one that can form purple solution in excess ammonia is the chromium. So we've got Cr3+ ion reacting with hydroxide ions. Again, when you're adding dropwise ammonia, it forms hydroxide ions. Look at the formulas. Oops. that is supposed to be a solid. Yep. And solution F, what is solution F? You see for solution F, what's actually happening is adding excess ammonia. You've got your ligand substitution taking place. So originally, you had 6 water molecules surrounding the chromium ion, but we're now adding ammonia, 6 of them. Ligand substitution takes place. The charge stays the same, and the 6 waters are given off. This is your compound F. What you've then got DEFG. So look, there's no, when you're adding nitric acid, there's no change. That means there's no carbonate ions, but nitric acid needs to be added first to rule out the presence of carbonate ions. And when barium nitrate is added, a white precipitate forms. That tells you that you're actually dealing with a sulfate. So you've got a sulfate ion present, SO42 minus. There's no sulfate ion in C, so let's do this one first. Compound, so there's G. G, you've got your barium ions reacting with sulfate ions to give you barium sulfate precipitate. Okay, that's G. And when you're, for B, when you're adding nitric acid, no change. Followed by silver nitrate, no change again. For solution C, no change. But you're getting a white precipitate. That tells you you're dealing with, you've got presence of chloride ions. So for H, the ionic equation is going to be silver ions, aqueous, plus chloride ions, aqueous, to give you silver chloride solid. Construct ionic equations. I think we've done that. We've got the ionic equations, we've got the ligand substitution. I believe yep, I think that covers them all. We missed any out? Chromium hydroxide. Yeah, that covers all the points. Hope that makes sense. In this question, you got a compound of nickel J has the formula. You got this over here. It contains thiocyanate ions and ligand ammonia ligands. The percentage by mass is given over here. You've got these percentage abundance values. These don't add up to 100. 66, 72, 80. These don't include hydrogen. No hydrogen. And no carbon. And they want us to work out X and Y. Let's work out the ratio between these, and then we'll assign them and play around with the numbers. You see nickel, sulfur, and nitrogen. Nickel You got 16.26. Sulfur is 35.56. And nitrogen is 31.00. Let's divide them by their corresponding relative atomic masses. 58.7, 32.1, and 14. You divide all of them by the smallest number, which is 0.277. That gives you 1. That gives you a 4. And that gives you an 8. So that means for sulfur, for every 1 nitrogen, there's going to be 4 sulfur. So X is actually equal to 4. Now nitrogen, there's 8. My screen's not responding. So there's 8 nitrogen. There's 2 over here. We've just established X is 4. So there's 4 nitrogen here. There's 8 in total. That means there must be 2 nitrogens in here. So that means Y is therefore equal to 2. Let's check the mark scheme on that. Yep, Y is 2, X is 4. Determine the oxidation number of nickel. You see overall, the ammonium ion here is +1, +1. The cyanate ion, there's 4 of them, and they're all -1 each. Ammonia is neutral. We've got 2 of those. Nickel, therefore, must be +2. Charge, and in this case, the oxidation number must be +2. Yep. What do we have here? We've got a redox titration question. How many marks is this worth? 5. Sodium sulfite is used as a preservative. Food safety legislation allows a maximum of 850 milligrams of sodium sulfite per kg of burger meat. The chemist determines the amount of sodium sulfite in a sample of burger meat using manganate titration. So what we got here? This much of burger meat is extracted to form a solution containing sulfite ions. The solution from step 1 is made up to 250, and out of this, 25 is taken, and a titration is carried out. It's acidified with dilute sulfuric acid and then titrated with this is used. Right. So we work from step 3. So for MnO4 minus, we've got volume. We multiply that by the concentration. This gives you the moles of manganate used. 1.26 times 10 to the minus 4 moles. This reacts with the sulfite ions in a 2:5 ratio. So for SO32 minus, ten to the minus 4. It's a 2:5 ratio. How do you make 2 into 5? You will divide by 2 and then multiply by 5. This gives you the moles in 25 centimeters cubed. Oh. Screen's not responding. 1 moment, class. My thing's overheating. Okay, I think I can't move my screen, but this is the last question. We just have to cram it in here. So that's in 25 centimeters cubed. We want to know how much is in 250 centimeters cubed. So we multiply that by 10. 3.15 times 10 to the minus 4 times that by 10 gives you 3.15 times 10 to the minus 3 moles. You see, that's the moles of sulfite in the sample. Yep, moving now. And so that's the amount of, that's the amount of sulfite in the solution that's been made up. Let's work out how many grams that would be of sodium sulfite. So 3.15 multiplied by 10 to the minus 3 multiplied by sodium sulfite, molar mass, what would that be? Na2SO3. Na2SO3 48 is the 3 oxygens and 32.1. 126.1. So let's multiply that by 126.1. That gives you 0.397215 grams. Now, what we want to do, we want to find out, let's convert. So that will be 397.215 milligrams, because we multiply that by 1,000. But that's how much meat is in 500. Sodium sulfite is in 525 grams of burger meat. So let's divide that by 525. This is how much is going to be in 1 gram. We want to know how much is in per kilogram, which is 1,000. And the answer is 756.6 per kilogram of burger meat. And oh, my screen is frozen. What was the, is this less or more than the permitted amount? I think the permitted amount, yeah, the permitted amount, I think it was 850. This meets the standard. Of permitted amount. Where are the 5 marks from? Volume times concentration, using the ratio, scaling it from 25 to 250, which is there, working out the mass of sodium sulfite, and then checking to see if it meets the standard, 5 marks. And the question paper. I'll see you tomorrow.